Okay, I want to talk to you about the kinematics equations, also known as equations of motion. So we're going to study how objects move, and we're going to do this mathematically. You can derive it using calculus. I'm not going to get into that. What I will say is that if we measure the motion of objects, there's certain variables we can always measure. So we can measure distance, and that is in meters. You can measure initial velocity, which is how fast you're going at the beginning. And that goes by v sub I, and that is in meters per second. You can measure final velocity. How fast is it going at the end? And if v sub I was your initial, v sub f is your final, that is also measured in meters a second. You can measure acceleration. How much does your velocity change? Now, the acceleration A is in meters per second squared. Although it's possible to have situations where you have a changing acceleration, in cases in this class, you're almost always going to see a constant acceleration. Except occasionally maybe with graphs, but for the most part, it's usually going to be a constant acceleration. And finally, time. How long does this experiment go on for? How long are you taking measurements for? Time t is just measured in seconds. So whenever you start a problem, it always helps to create a table with these variables. So this would be my table now, and I'm just going to say d, v sub I, v sub f, acceleration in time. And what we find is that in order to figure out what's going on in this problem, there's 5 variables, but you only need 3 of these to figure out what's going on in the problem and figure out the other 2. As long as you know of 3 of these, you can figure out the other 2. There are occasional exceptions with projectiles, typically, or constant speed problems, but usually you just need 3. They don't always specifically give you 3, and one of the challenges in reading a question is decoding it and figuring out what they're actually telling you. So there are keywords. For example, if you see constant speed tells you that your acceleration is 0. Just an example of one of them. So let's just start with this table here, and then I'm going to put up for you these kinematics equations that you're going to use. These are given on the reference table, and there are 5 of them. You don't even need all 5 of them, honestly. Some of them, like, well, acceleration equals a change in velocity over time. You saw that already? Well, that's just being rewritten as Vf equals Vi plus At. So these really are just variations in the same equation. V bar. So V bar is your average velocity. It's just distance divided by time. And this is what you've been using for constant speed problems. The thing that you don't necessarily see on the reference table is what V bar really means. So your average, right? It says your average velocity. Average is just add 2 numbers up and divide by 2, right? So your initial velocity plus your final velocity divided by 2 is equal to distance divided by time. And this is a shortcut that can help you do certain problems more quickly. Delta V is V final minus initial. How much does your velocity change? We'll figure out how much you're going at the end, subtract how much you started, that's delta V. These 2 boxes are not on the reference table. The other 5 are. So let's do a couple of examples to see how this works, right? So let's say you are speeding up. And you know that you're going at an initial speed of 5 meters per second. You know that your acceleration is 3 meters per second squared. And let's say your time is 2 seconds. You want to know how fast are you going after 2 seconds. You could start with the same situation and change the time to 4 seconds, and it would just tell you how fast are you going at 4 seconds. Put in what we know. 5 meters per second. Acceleration is 3 meters per second squared. Time is 2 seconds. There's 2 variables we don't know. The benefit of these equations is that you should almost always be able to find an equation that has 3 variables that you know and the one that you do not, because each of these has 4 variables in it total. None of them have 5. So let's find an equation that works. We want to find out how fast you're going after 2 seconds. Let's see. We know we want to find VF. We know VI, A, and T. We don't really even care about distance. So we could say VF equals VI plus AT. This has got the 4 variables that we either know or need to know. VF we don't know. VF equals your initial speed of 5 meters per second plus acceleration, 3 meters per second squared, times time of 2 seconds. We're just going to solve it. You end up getting 5 meters per second plus 6 meters per second. For your final velocity, then is 11 meters a second. That
this is Sobran. Please
example.
call extension 30082.
I want to do another example here. Let's say you are, instead of speeding up, we're going to do a slowing down example, and I'm going to change some of the variables. So every time we need to figure out what we know, what we need to find, and what we don't care about. So let's say you're slowing down. You start an initial velocity of 10 meters per second, and you come to a stop. Well, if you come to a stop, it's not explicitly said, but you can figure out your final velocity has to be 0. That's what coming to a stop means. So it could just say you're going at 10 meters a second, you come to a stop and you travel a distance of, I'm going to change it to D, 30 meters. And then we can look again at the kinematics equations. Maybe the question is, how long did it take, right? So let's think about this. We need an equation that has time, final, initial, and distance. We don't care about acceleration. Sometimes it gets a little tricky, but we can still find something. So let's stick with this one, V bar equals D over T. You know, if the worst case scenario you can't figure out at first, you can find the acceleration. And with the acceleration, you can usually fill in the last variable. We have initial, distance, final. We don't care about acceleration. This is one of those tricky ones I probably shouldn't have given you to start with. Because well, it's fine. Okay, V bar equals D over T. So we can say average velocity here, V bar, is just, you start at 0, you start at 10, you end at 0, 0 plus 10 divided by 2 is 5 meters a second. That's your average velocity. You can do that in your head, for example. And so then we can say V bar is equal to D over T. So 5 meters per second is equal to your distance of 30 meters divided by your time of unknown seconds. We can move this from the bottom to the top. We can move this from the top to the bottom. So rearranging, I get T equals 30 meters divided by 5 meters a second. And that works out to be 6 seconds. So I hope this gives you a sense of how we're going to use the kinematics equations. We're going to have some practice on this in class as well. So thank you very much for watching.